So we shall discuss about Kolbe's reaction. Right. So while writing the Kolbe's reaction, from the name itself we can find out the reactant and product. Here this OL stands for phenol. So this OL stands for phenol, right? And this S stands for salicylic acid, right? So that is a reaction. Got it? Phenol gets converted into salicylic acid. That is Kolbe's reaction. Now let us have a look. So what happens here? We have to add first a NaOH, and second we have to add a CO2, and then we have to hydrolysis. So these are the things, right? If the question comes like this, that is phenol we treated with NaOH, CO2H plus. So what is the product here? So immediately we have to understand that there is nothing but Kolbe's reaction. The product is salicylic acid. Okay. Now is it clear that phenol when treated with NaOH, what happens? Now let us take phenol. When it is treated with NaOH, so what happens? So this get moves away, H2O gets moves away, and we are getting ONA, right? And O plus Na minus actually. And then if you are treating it with CO2 under 400 Kelvin and 4 to 7 atmospheric pressure. So here we can remember 4, right? 400 Kelvin, 4 to 7 atmospheric pressure, we can get salicylic acid, right? COH, OH. Now actually this is acid is a main group here. Acid is a functional group here. So it can be considered, it can be called as benzoic acid. This part is called as benzoic acid, right? And this part is in ortho position, there is a hydroxyl group. So it can be called as orthohydroxy benzoic acid, right? Orthohydroxy benzoic acid. Now we can go for the mechanism of the reaction, right? So first, sorry for my handwriting, try to understand that. First we'll take phenol. Right. Now what happens? This oxygen is being electronegative, it pulls the electron towards its side. So at the time what happens? The NaOH provides a OH minus ion, right? So this OH minus ion gives its pair of electron to the hydrogen and abstracts the hydrogen, right? So what happens here? Now this O minus, it becomes O minus itself because it's taken the electron from the hydrogen, plus the hydrogen has taken the, what is that? OH minus has taken the hydrogen from here, plus H2O. Let us write H2O. Now what happens at this stage? This oxygen donates its electron to the ring and activates the ring. So what happens? This electron comes here. So this electron tends to stand here due to resonance. So we can write like this. So now this electron has gone here, so that is double bond O. So the electron stands here as a negative charge. The remaining bonds are there. Now at this stage, what happens? The CO2 attacks. We know that the carbon dioxide is acidic in nature. So what happens? Acidic in nature means there is a necessity of an electrons. So the electron goes here, or the carbon dioxide takes this electron. So what happens here? The carbon dioxide comes and attaches here. So here 4 valency is satisfied now. So another bond is forming here. So in order to maintain valency, the oxygen takes away its electron. So what happens? Here double bond O as usual. So 2 bonds are there as usual. And here the carbon makes a bond. right? C, and here O minus, one of the bond has been shifted to the oxygen as electrons, right? And here double bond O, and here there will be a hydrogen, right? So CH2, there will be a hydrogen here. Now what happens here? This oxygen abstract this hydrogen without electrons, and this electrons moves inside the ring at this place, right? And because of that, the oxygen takes back its electron. So what happens, again I'm coming here, this oxygen gives its pair of electrons and abstracts this proton, abstracts this hydrogen, and these electrons which are in the bond of hydrogen and benzene shifts towards the inside of the ring, right? And by this action, the double bond, the oxygen takes its electron back and there becomes a single bond. Is it clear? Let me write it here. So now the oxygen has taken back its electron, so it acquires a negative charge again, right? And here a double bond comes here, as usual the other two bonds are here, and here the C double bond O is there, and here this oxygen has abstracted this proton, so OH, right? COH, this is a product now, not product, it's an intermediate now, right? Now what happens at this stage, acidification takes place. We are providing a H plus ion, so automatically this H plus ion will join with this O, so we can get the ultimate product OH COH. So the rings of the bonds are filled. So it has been, the aromaticity has been retained. Is it clear? This is salicylic acid.